So funny story. This is my third time recording this because the first time I recorded it, Zoom didn't hit record. The second time I recorded this, I was muted. So that's how we're doing today. Yeah. So if it feels a little disjoint from how it usually is, my usual cadence, I am so sorry. So today we're covering the limit definition of a derivative. It's going to be chapter 2.x sub 2a, I think, or something silly like that. Yeah, I had done all this, and yeah, it's been a morning. So to talk about this was all motivated by slope, right? So let's go back to slope. Slope, as some of us may write, is going to be rise over run. It's also going to be written as delta y over delta x changing y over changing x. It can also be written as y2 minus y1 over x2 minus x1. And these are all like super fine and valid, right? But where am I going with this, Heike? I see. Um, so for our purpose, we're going to use y2, y1. Slope written as y2 minus y1 over x2 minus x1, right? And from there, you can start saying things like, oh, well, what if we have a function, right, like f of x? Then can we write y2, y1 in terms of x2, x1? The answer is yes, we can. The first part will be y2 becomes f of x2, right? And the second part will be y1 is equal to f of x1, because x1 goes with y1 and so forth, right? So, this is so great, guys. But if we look at it another way, right, on a number line, x1 and x2 is drawn like this, and the question is, can we write x2 in terms of x1, given like some distance h, right? The answer is yes, we can. x2 can be written as x1 plus h plus the distance, right? And so that means we can just replace x2 with x1 plus h, right? So it's going to give you f of x1 plus h. I'll write it in purple for you so you can see a little bit better. F of x2 minus f of x1 all over x2 or x1 plus h in parentheses minus x1, right? But fundamentally, we have a little oopsies in the sense that x2 doesn't exist anymore. So actually, we want to rewrite that as replace x2 with x1 plus h. Okay. God, I would make a terrible YouTuber, huh? Please do not write f of x1 plus h as f of x1 parentheses plus h or f of x1 plus f of h. That's almost never true for most functions. All right. Okay. Parentheses are important. But fundamentally, right, the whole point of having x1 and x2 was because we had two different x's, two different arbitrary x's, but two different ones to begin with. But if we work with just one arbitrary x, right, just pick one, any one kind of thing, you can just write it as f of x plus h. We don't need to make a distinction anymore. And then minus f of x all over x plus h minus x. Beautiful. It's like, here's the thing, right? Like, everything works fine when you're working with a linear function, but when you're working with a curve, slope function don't quite behave the same. That's why we have that whole notion of distance, right? Like, we want smaller distances. And so what we're going to do is, we want that distance to be smaller, so we want h to approach 0, right? So that's exactly what we're going to do. We're going to pop in a limit, like, just for the vibes, right? The linear functions don't need that limit, but the curvier functions do. Technically, all lines are also curves, but that's a whole different can of worms, right? But curves are a more general form of lines in this sense. So we're gonna put that limit in. It's gonna be great. So then we're gonna write as the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. Easy money, right? Nothing crazy here. But then, hear me out. We can't simplify the top because we don't know what that function is, but we can simplify the bottom. So we're going to rewrite it as the limit as h approaches 0 of f of x plus h, because again, it's called darker. Oh, it is. Oopsies, hee hee. As f of x plus h minus f of x all over h. And this might be familiar to some of you, because this is the limit definition of a derivative. Ooh, fancy. I hate doing voiceovers, yo. And so what is a derivative? Well, we got all this from slope, so hopefully, right, it's got to do with slope. In fact, this is the slope function for some function f of x, which we'll write as f prime of x for now. There are other ways to do it, or to write it, but we'll get into that. An important note, and I'm not going to rewrite this, is if the derivative doesn't have the same limit on the left and right hand side, there's actually no defined derivative there, which means the original function is not differentiable at that point where the left and right hand limit is not the same. We'll get into it, don't you worry.
Okay, and so that idea of continuous and differentiable will come in handy later, and I'll explain to you guys when it comes up. Let's do an example of a function that is continuous but not differentiable at a certain point. Usually when we say continuous and differentiable, we mean at all points. And if we say it's not continuous and differentiable, we usually mean at a very, very specific point, okay? This one section I actually wanted to record again because I want to be very, very clear. So let f of x equal the absolute value of x, right? So functionally, right, it would probably look a little bit like, actually let's center it. Probably behave a little bit like this, right? Where you have, this is like x equals 0, y equals 0, right? And then you have when x is greater than 0 and when x is less than 0, right? So if we take the limit of this function, right, heading towards 0, I mean, like this side behaves like a linear function, so does this. The interesting point is right here, right? If you take the limit as x approaches 0 of absolute value of x, you're going to get 0, right? Left-hand side heads towards 0, right-hand side heads towards 0. Okay, so limit does exist. Now let's check the continuity. F of 0 is equal to the absolute value of 0, which is 0. Cool. That works. But now let's try to take the derivative of it, right? Okay. So let's note that f prime of a is going to be the slope of f of x at the point x equals a, right? And so do you remember those various forms we could use where we could say like, oh, the limit as h approaches 0 of f of x plus h minus f of x all over h. But you can also write it as the limit as h approaches 0 of f of a plus h minus f of a all over h, or f prime a in particular, right? Like this gives you a general function. This gives you the specific slope at a specific point. So if we use that same methodology, right, what you can do is you can say, oh, I want the limit, or I want f prime of a, which is going to equal the limit as h approaches 0 of f of a plus h minus f of a all over h, right? And as we established, we know what f of x is, so we can just kind of plug things in, right? So the limit as h approaches 0 of f of a plus h, right? What you're doing is you plug this into f of x. Alternatively, another way to say that is every time you see x, replace it with a plus h, right? So that's going to give you a plus h, right, minus the absolute value of a all over h. But note, we want f prime of 0, right? So that means we can write this as f prime of 0 equals the limit as h approaches 0 of a is equal to 0, so 0 plus h minus 0 all over h, right? And then you can say, oh, the limit as h approaches 0 of h over h. But here's the problem, right? We describe h as the difference between some point, right, and slightly off that point, right? And so visually, right, they call this an open neighborhood. You don't need to know what that means, right? What you're really looking at is you're saying, oh, this is x plus h, this is x minus h. And they should be going to the same place, right? If you like this kind of math, it's called analysis. I highly recommend it, right? But what you're doing is you're taking a bubble of some distance h around x, right? But if you were to do that, you will find that you run into the issue of as the limit h approaches 0 from the left of h over h, as opposed to the limit as h approaches 0 from the right of h over h, right? Again, this is some analysis magic. You don't have to know this, okay? This is always going to be positive, right? The top will always be positive. Top is positive, bottom, if you're coming from the left of 0, the bottom is negative, right? That means you're going to get a positive over a negative. And it's going to be the same number, but they're going to have different signs, right? Which is going to be negative something. In this case, -1, right? Because h divided by itself, right? On the other hand, when you do it to the side, right, you know that this is going to be positive h. This is also going to be positive h, right? Because from the right-hand side of 0, right, h is positive. This is going to give you positive h over positive h, which is going to give you positive 1. Right? Top is positive, bottom is positive h over positive h is positive 1. On the other hand, top is positive, bottom is negative, positive h over negative h is negative 1. And so the limit, right, as h approaches 0 of abs h over h does not exist. If that doesn't exist, then neither will this. Okay? So the function is not differentiable.
I'm gonna have you guys do the guided practice problem. I'm not gonna do the voiceover.
Yeah, this is Baby's intro to proofwriting.
Really sad.
Woo!
Because this is like the third time I've had to record this. So don't worry, I do lots and lots of pictures and lots of colors, and you guys should be able to follow it. Yeah. Okay.